Hi there, Kaiweets sent me their latest version of the KM601, the KM601s, for review. I did not pay for this meter, so I marked this review as promotion, but you know, you always get my unbiased opinion about a product, and I'm afraid this review did not end well for the KM601s. I also shortened it drastically to get to the point quickly. At first glance, the new S variant is very similar to the older KM601, which I reviewed and recommended a while ago. The only real difference is that instead of 3 AAAs, the new model uses an internal rechargeable lithium battery. The display color scheme is slightly different, but an improvement in my opinion. The red auto function button finally goes both ways, left or right, which is a significant improvement. Gone is the old problem of pressing it once too many and then always have to go the long way around by pressing it another 10 times to get back to the function you really wanted. The KM601s retains the brilliant way of showing which sockets to use for each range, or automatically selecting the milliamp or amp function when you plug a lead into the corresponding socket. This avoids many beginner mistakes. The accuracy specs and display count are exactly the same as the old meter, but I did put it through its paces, and on that, everything is as it should be. Some things got even better. I complained that the old KM601 had trouble measuring very low resistances, below 25 ohms or so. The lower you got, the larger the error. Kaiweets managed to fix that problem too, like in this demonstration. 0.5 ohms is nearly correct. 1 ohm is spot on. 1.8 instead of 2 ohms, that's still acceptable. 2.6 instead of 2.5, also okay. Overall, low ohms is still not brilliant, but much improved over the KM601. Not all annoyances were fixed. The separation of the sockets is still slightly smaller than the standard width, which rules out using BNC adapters with this meter. While verifying the milliamp range, I accidentally increased the current too much. I quickly lowered it, but it was too late. Now I just get a lead message even though the lead is plugged in. Moving into the amp setting shows the right value, and now it shows a fuse symbol next to the milliamps. That is nice. And with no leads and selecting milliamps, it clearly tells me what the issue is. I love that. What a great way of helping beginners. I suspect the KM601 does the same, but this is my first blown fuse with either of these meters, so I wanted to show it. To get the fuse out, you open what used to be the battery compartment. Of course, that has been redesigned and provides access to the fuses. I wish they would better indicate which fuse is which. It is shown, but only on the lid, which I just removed. The fuse body is completely blank, but one cap shows 630 milliamps at 250 volts and UL markings. The values match what's printed in the manual and shown on the front of the meter. This gives me an opportunity to check if it has sand inside. And indeed it does not. But then this meter does not claim any CAT ratings either, and for normal household use this should be okay. The fuse has thick walls and should handle that. The charge cable plugs into a very deep recessed socket behind the rubber bung. I wanted to know if the charge cable is isolated from the input terminals, because that's where danger lurks. The resistance between the USB negative against the COM terminal in volt mode seems to fluctuate, but it's not always infinite. In ohms or continuity mode, it's about 17 meg, but also sometimes changing. 11.5 meg in diode mode. Open in capacitance mode. This is what I hope to see across all ranges. If the charge lead is somehow connected to the input terminals, all kinds of bad things can happen. But first, plugging the charge lead into a 5V supply turns the charging on. The KM601s shows a nice animated charge bar and draws about 0.5 amps. At the same time, the keypad is disabled, which is supposed to prevent you from trying to measure something while charging. Hard to overlook, it clearly tells you when charging is done. That full screen goes away as soon as you unplug the USB from the charger, and the meter is now fully functional again. Unplugging on the charger side is enough, in fact, just turning the 5V power off. The firmware does not realize that I have not unplugged the charge plug from the meter, and now I have a dangling USB lead that's still connected to the inside of the meter. So I put 230 volts AC mains on the meter with the yellow live wire in the COM terminal and the blue neutral in the volts ohm. It shows it, of course, while I use my BM869S to see if there's any significant voltage between earth and the USB cable. Well, there is, but just a few volts. How about the current? After a quick reconfig of the BM869S for measuring current in the milliamp range, very little, much less than a milliamp. So I decided to use the microamp range. Nearly nothing. Here's the principle of what I was doing. On the left is the KM601S and on the right the BM869S. As you saw, there was hardly any voltage or current shown on the BM869S. Happily, I turned the camera off and I was just about to dismantle the setup when I noticed that the green earth lead was very loose in the socket of my mains access box. I pushed it in further and wiggled it a bit, and since everything was still running, I touched again the USB connector with a test probe. Oh boy, a big blue spark at the probe tip, a pop sound, and the KM601S was dark. I turned the camera back on immediately, and what you see is just a few seconds after the disaster. This is basically what I did. Fix the green plug, and then touch the USB connector. Interestingly, mains is still running. No circuit breaker or RCD tripped. This must have been a super fast event. But very powerful. It blew the massive 440 milliamp fuse of my BM869S, which costs around $10 US to replace. The current surge must have been so strong that the fuse blew faster than any RCD or GFCI could react. Still, I'm very happy that the BM869S managed to protect me and itself despite being in the most sensitive microamp range, because after replacing the fuse, it was fine. The same can't be said for the KM601S. The display was dark, but the torch light had come on by itself. Pressing the on-off button did nothing. Also trying to charge did nothing. I opened it up. Since it felt quite warm, the first thing was to disconnect the battery. And then I inspected for signs of damage. Spotting nothing obvious on this side of the PCB, I tried plugging the battery back in the hope that being without power for a while may have reset a locked processor. But no, pressing the power on button just brings on the torch LED. The display remains dark. I then took the PCB out completely and removed the display. And there on the back, close to the on-off switch, was a burn mark, but I guess most damage is really in one of the inside layers. Well, this KM601S is literally toast. When reporting this to Kaiweets, they told me they know that the meter would burn, as they put it, in such an event. Okay, the meter is burned or dead, but much more serious is that the same could have happened easily to me. If I had touched the USB connector, I would have suddenly received a serious shock, especially if I would have been somehow grounded. One of the rules in such tests: only use one hand, don't touch anything else, don't lean or sit on something, and wear isolating shoes. Since we have RCDs or GFCIs installed on every circuit in the house, it would probably have not killed me, but such protection is certainly not everywhere. And starting measurements with a charge lead still attached is easy to do, especially for beginners, for which the KM601 is basically made. The manual contains no warning whatsoever about charging or the danger the charge lead may cause, but then relying only on safety warnings in manuals wouldn't be good either. Who reads manuals? A system has to be intrinsically safe even if you haven't read the manual. Kaiweets told me they rely on the fact that the meter display and keyboard is locked while charging. That might be so, but nothing stops anybody keeping or plugging in test leads into the terminals of the meter and connecting the leads to a live circuit while it's charging, with possible serious consequences. Further, as I showed, the lock goes away by simply unplugging at the charger end, exposing the now dangerous USB plug. A simple improvement would be to have a contact in the socket that senses when the cable is unplugged and make the unplug event the only action to release the lock on the display and keyboard. That would not prevent users from connecting the meter to live circuits while it's charging, but still better than the current situation. Other companies that offer rechargeable meters have of course the same problem. Agilent solves this by using the meter terminals to connect the charger. That's a good idea, but I'm still somewhat skeptical that they leave 2 of the 4 terminals free for the user to possibly fool around. I have no doubt that Agilent solved that somehow, but why exposing these terminals in the first place? If I were Kaiweets, I would have designed a special charger plug that, when inserted, covers all 4 terminals. That way nothing bad can happen even to total beginners. It can't be that expensive, just mostly plastic, I imagine. Sadly, the reality is what's here in front of you, a dead meter that can also cause serious harm to the user. The KM601s would have been a solid recommendation, improving on the KM601 while removing some of its quirks. But the charging system is way too dangerous. Don't buy it. If you like the form factor, go for the KM601 instead. It has the same specs but uses much safer AAA batteries and works quite well with rechargeable ones. If you like my videos, don't forget to subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided becoming a Patreon. That would really help this channel. Thanks for watching.